Hi everyone, this is Crash Me Twice, and today I would like to show the final steps of the WarBRD damper mod project. I start by attaching the damper mount to the T-slot rudder assembly. I'm using on the inside a banjo fastener and on the opposite side a elbow fastener. I don't use on the 4042 banjos as this would weaken the profile. A quick test aligning of the damper to make sure it fits correctly before I move on to the actual mod of the damper itself. I removed the end cap from the damper shaft by applying heat to it. This cam is just held with glue and the heat allows me to simply pull it off while it's hot. A fine grit sanding sponge helps me with removing any leftover glue. Now the complete disassembly of the damper starts. It's a messy job, but somebody has to do it and might as well be me. All I will be using for this whole disassembly is a crook nose plier, a hex driver for the knob, and a small screwdriver to remove a spring or something. All of this does not require any force at all. The knob is held onto the shaft by a small set screw, and the hex driver is needed to loosen it, and this allows the knob to be pulled off. The piston, which pressurizes the fluid, is held back by a steel ring, preventing it from moving out of the cylinder. To remove the ring, I need to push the piston in and then take the ring out. A small screwdriver does a perfect job. Next I take out the piston and its spring. I then move on to the valve chamber, and I can clearly see the two ports for the liquid to pass through. One of the chambers is regulated when turning the knob, which drives the conical pin into the hole. So deeper that pin goes in, the harder it becomes to move the damper, as flow is more restricted. The other one is a fixed port. After taking the main piston tube off, I can begin to machine the upper body, as I will be making a secondary bypass which can be operated independently from the regulator. This will allow me to switch from hard, or whatever the setting is, to almost fully unrestricted state instantly. I saw this in the cockpit video of an Mi-8 helicopter, in which the pilot hit a switch on the left upper panel to achieve this. I want to be able to do the same on my rudder system. So first off, a flat surface is required, and I machine that up, followed by drilling the holes for the bypass, and these holes line up with the holes inside the chamber. Being precise here is important. These holes are 1/8 inch in diameter, and 2 drill bits help me to stay aligned. I also have to mill a pocket for each hole to place O-rings for a good solid seal. For testing I use standard O-rings, but I will replace them with Buna nitride ones at final assembly. Only the Bunas are rated for hydraulic fluids. Looking through the chamber holes, I can now see the light entering where I drilled the bypass holes. Now I have to create a bypass valve system and a bracket to hold it onto the damper body. I am using 3/4 inch 6061 aluminum for it. I need to create a recessed shoulder for it to fit over the remaining rounded part of the upper body. The bypass valve needs to align perfectly for this to work. I'm drilling the holes leading to the holes I drilled into the damper. At the same time, I'm drilling the holes which will hold the bypass valve to the damper with a bracket on the opposite side. To say it simply, I'm clamping my assembly to the steering damper's upper body. Next, I am creating a recess on the left and right side of the bypass valve for a mounting plate. This plate will hold the servo to actuate the valve. I'm milling a pocket into the new bypass valve body, covering the outer edge of both holes. The bypass valve consists of a chamber in which a rotating stem turns. I'm turning this part from a piece of stainless steel I had in my scrap bin. The stem needs a groove for an O-ring, so that fluid cannot leak out of the sealing arrangement. I then mill a 1/8 inch wide deep slot into it, where the fluid can pass through if the stem is in a 9 to 3 o'clock position, and is stopped when in a 12 to 6 o'clock position, if that makes any sense. Simply said, an open and closed position. The remaining shaft of the stem is milled flat on one side, as I will be using an actuator to drive it, and a set screw to lock it into position. I also make markings for fluid pass and non-pass position into the stem and the valve body. They will be color coded to enable me to see in which position the stem is after all is assembled. Next, I'm drilling 2 holes and thread them for bolts which hold a washer in place, which serves as a bonnet. A bigger diameter washer is usually made from thicker material than a smaller one, and by filing a groove on each side, I am able to fit it within the given space. A small round file gets this job done nicely. The grooves also prevent it from shifting sideways. If I need to access the internals, I can easily remove the bonnet at a later point. Next, I will be creating the back bracket using 1/4 inch aluminum 6061, cut to size, drilled and tapped. Now you can see the completed assembly. My next step is to make a servo mounting plate, which will be mounted horizontal to the valve body. I am using 1/4 inch aluminum plate as usual. I then make a cutout for the servo to sit in, and I drill 4 mounting holes for the servo to be secured to. One edge of the mounting plate is milled down, and this gives me a bit more room for adjustments on the T-slot setup I use. Hard to explain right now, but I'll show you in a future video when the damper system is installed in my sim pit. Anyway, the servo will turn the stem into the closed or open position. And here you can see laid out all the parts involved for this system to function. Now the damper is reassembled with the added bypass valve I've made. Filling it with Lucas 15 weight fork oil in the video, but after it was all said and done I had to redo it with 20 weight. I felt that in my case the higher viscosity oil was needed with the bypass. I am changing the joint in the damper mounting bracket to a bushing. I forced the joint out from the bracket by simply using a wrench and a socket in my vise. After careful measuring, I turn a bushing from brass rod in my lathe. The bushing is then pressed into the bracket. I'm finally at the point where everything is put back together. All what's missing now is the actuator arm, which I'll be making next. Using again 1/4 inch aluminum from the scrap bin, some machining required. A center hole for the stem is drilled, as well as 4 additional holes for the push rod. It's all about adjustability. One corner is machined down flat for a threaded hole, in which a set screw is used to hold the actuator arm in position. Of course, the set screw I had was too long, and with no shorter one at hand, I had to machine it down to size. Finally, my new high-torque Metal Gear servo has arrived. I especially like the aluminum servo horn. Go figure. Let's get this puppy installed and hooked up. Shiny little servo horn. Now I'm good to go, and the last step is to add a servo push rod and electronics to drive the servo with a toggle switch. The motor damper is installed using a bearing on one end and a simple washer on the other. I turned one of the lock nuts a hair down so that when it's tightened, it doesn't rub on the bearing. All finished and all is working. I think that it came out really nice and I'm quite happy with the result. The electronics and the installation into my sim pit will be shown in detail in upcoming separate videos, so stay tuned. And here we are. As always, I am planning on making more projects in the future, so please keep an eye out for my next video. Hope you all enjoyed the final part of this build and hope I earned a like from you. Crash Me Twice, out.